Hello everyone. With the recent advancements in the field of LLM, especially moving towards quantized LLMs and making very good performing LLMs in very less number of parameters, now it is possible for us to run LLMs in our own Android devices or iOS devices. In this video, I'm going to show you all how you can create a mobile app in which you can run your own LLM locally in your mobile itself. And for this, I'll be using Gemma, and I'll also show you how you can use your own custom LLMs and run it on this application. At the end, you'll be building an application like this, and now I'll show you a demo of what we will achieve in this application first, and then we'll move on to the code part. Now, as you can see here, I have Mediapipe in my Android device, and I'm going to open that. It is opening, and as you can see here, it is showing my Mediapipe LLM inference and response generated by user provided model. The application is opened, and now I'm going to type a question for this model. What is machine learning? So as you can see here, I have typed a question, what is machine learning? And now I'm running it, and it is generating in my mobile. This is completely in CPU and not in GPU. Okay, and this is completely running in my mobile phone and not in my laptop or anywhere else. And as you can see here, it is giving the results in great speed, that too in my mobile phone itself. The results are also pretty amazing, I'll say. So this is what we'll achieve at the end of this video, where you will also know how to build an application like this to run your own LLM in Android devices. So right now you would have seen a demo where I ran a question of what is machine learning, and it gave a detailed response where it would be of maximum 120 tokens, because that is how I set for the LLM. And now I'm going to show you all how you can do this with the help of Mediapipe. Mediapipe is a library or a package from Google for the developers. It has support for a lot of tasks, and as you can see here, there is support for landmark detection, there is support for face stylization, lot of vision tasks. They haven't focused a lot on NLP, but right now they have started to focus on NLP as well, where they now give support for inferring LLMs. Okay, so we are going to follow whatever it is given in this inference guide for Android. Okay, so you should have all of these ready. So for this, you would need the following. So let me go to Canva. First, what you would need is, you would need a LLM which is quantized and is in TFLite format. Okay, that is very important for you to run your LLMs in your local machine or your local mobile devices, or even edge devices for that matter. Okay, TFLite is TensorFlow Lite, and that is again a framework of Google. Okay, so if you don't know how to convert your model into TFLite model, don't worry. Still, I'll also show that how you can do quantization and conversion of your model into a TFLite model. All will be covered. Okay, so after that, you need to clone the application repo. Okay, so this is the repository where they give a baseline for your LLM inference application. If you think, okay, I'm not going to customize a lot, I just want to run my model in mobile, yeah, you can follow this specific code itself. And if you want to customize the UI, if you are a good Android developer, still you can make some changes in the code part as well. But right now I'm not going to do those and all. Okay, because our aim is to run the LLM in our mobile application, not to build a good UI and all, right? Okay, so once these are done, what you would need to do is, you would need to set up your emulator. Okay, so for this instead of emulator I use my mobile device directly. I'll also show you how you can do that, but it is required for you to have an emulator. Before that, you'll also need to have Android Studio and emulator, for which you will need an Android phone with version more than 7 and developer mode enabled. Okay, these are the requirements for you to have for this specific application. Okay, so first let me show you how you can quantize your LLMs and store it in TFLite format. Here there is an notebook, Jupyter notebook. This is from Mediapipe themselves. What you need to do is, for now they have given support to 4 to 5 models. Okay, they have support for Gemma, they have support for Falcon, Stable LM, and I think they also support Phi actually. Okay, so because these are the models which are available in low parameters. Now I'll show you how we can execute this. So first what you need to do is take a copy to your drive if you want to. In setup, if you see, they are installing Mediapipe, Torch, Hugging Face Hub. Let it run. If you are, let's say in our use case, let's say you are downloading Gemma. Okay, you will take the Gemma folder or the Gemma model from Hugging Face Hub, and in that we are considerate about 2 specific things only. One is the model and another is the tokenizer. So for tokenizer we need tokenizer.json and tokenizer.config.json, and in model we need model complete model, and here if you see it is 2 shards. So here it is 00001 and 00002. If it is 10 shards, you need to load 10 shards. Okay, so those parts are given. You need to provide your Hugging Face token and then we'll download it. Okay, so that is the first step where you need to download it. Okay, so once you are downloaded, next what? You need to have it in your local, like I said, and then in Mediapipe itself there is a specific converter for you to convert any of your models into TFLite model. Okay, any of your PyTorch model or Safe Tensor model. There are only 2 formats which is supported right now. One is PyTorch bin file and normal Safe Tensors file, which is a conventional format used in Hugging Face right now. What you need to do is, you need to provide your input checkpoint, which is your path in which you downloaded the model now, and then for vocab model file also provide the same path. And for output directory, what you can do is provide intermediate directory. Okay, next, finally, this is the most important path, which is your path for saving the TFLite file. See, necessarily TFLite file need not have the extension of .tflite. Okay, you can have it as .bin as well. That is also correct only. Okay, so here I'm storing it at normal content is the root directory in which we work in Collab. In there I'm creating a folder known as converted models, and then I'm storing it as Gemma underscore backend. What is the backend? Backend is in which device you are gonna run or which backend processor you are gonna use. Is it a CPU processor or a GPU processor? Right now in our case it is CPU, so it will become Gemma CPU.bin. Okay, so input checkpoint format, model type is Gemma 2 billion, backend is obviously CPU, output directory is given, combined file only should be always false, your vocab model file and output TFLite path, everything is provided. So what will happen is here they have given a UI. Okay, if you click Gemma 2 billion, that conversion of Gemma 2 billion function will be executed here, and then once that is done it will be saved. Okay, but now it is in your Collab, not in anywhere. Like if it is also harder to download from Collab, and it is not safe to keep it in Collab itself because you might need to rerun it and you can't keep on running it here, right? so you can save that in your Google Drive. So for now, what we'll do is we'll run this code. We are taking Gemma 2 billion CPU, right? So let's run start conversion. Yeah. So until that is being done, let me also show you what happens here. So once your conversion is done, you will mount your drive in here, and then those will be stored in your Google Drive directory, which is converted models. It is provided here. Okay, in your converted models in Google Drive, this will be stored. Okay, so that is what happens. And don't forget, you need to have a Hugging Face token for this. Okay, that is very important for this specific task to be done. I have already provided it in my secret keys, so it won't ask for me, but for you it will ask. Okay, so it will take a 5 minutes or 6 minutes. Until then, I'll just see you later. Now if you see here, previously it was written converting in this button, and now it has become start conversion again, right? Which means the conversion is completed. Now we can save this in the Google Drive. Now it will ask permission. You can just give connect to Google Drive and it will be fine. Here if you see, I have Falcon, I have some other models as well. So let's say your model is Falcon, or in this case Gemma CPU, whatever you have it. Okay, so let's say it is Falcon CPU.bin. Let's say instead of Gemma you created Falcon. Okay, what you need to do is first download this model. Okay, put it in somewhere. For now I'll just keep it in here, and I'll keep it in my work directory itself. Okay, it will download now. So once this is downloaded, next what we need to do is we need to clone the repository. Okay, so let's start with that now. So now I've fired up my command prompt. So what you need to do is probably take your git bash. Okay, let me zoom it up here. In your git bash, first run these commands. You have these commands, right? You need to run all of these commands: git clone, http, github.com, this one. Okay, so for this, what I'm gonna do is I'm gonna create an empty folder now. Let's say it is make directory Falcon Android. Okay, I'm gonna create that. Now let's do a cd to that. Now paste that command. Okay, git clone. But the problem is, instead of this whole instead of this just Android example directory alone, we'll have whole of the Mediapipe library itself with us. That is not needed, right? So for this also they have given a solution where they have said that if you want just the Android example directory alone, so you can run these commands, is what they have said. So let's run that too. Okay, now this is done. We are gonna run this now. Okay, first let's do a cd Mediapipe. Okay, now this is done. Let's do this now. Git sparse checkout init -- cone. And finally, if you do this git sparse checkout set examples LLM inference Android, right? Now, if you see ls, it will have only examples. And if I go inside examples also, it will have only LLM inference. Okay, that is what you get when you do this specific commands execution. Okay, now the first step of having a model is done. Okay, because you have created a model now. Okay, you have the working directory, you can just have that model there. That is how you will have your custom model in there. Okay, they have said like you can use Gemma defaultly, but that is not needed for us. Okay, now what we'll do is, again, we have done this model part. They are saying about this. Instead of these following hereafter, just follow what I'm gonna say now. First one you need to do is go and download Android Studio. Okay, download Android Studio by clicking the button here. Okay, it will be a just simple implementation. Just do next, and you will be fine. Okay, so once that is done, what you need to do is open the Android Studio. Okay, let me show from first itself of how you can do that. For you, it will show new open project and all. So what you need to do is click open project in there. Okay, you will get a box like this, and here now we created Falcon Android, right? So you can go into Falcon Android example LLM inference. Okay, LLM inference Android, till this you can go. Okay, let's go to this. We are stopping this. Let's just click trust project. Okay, now we have sorry, it is just doing something. So what you need to do is, the next step is go into the application. Inside that, go into source, Java, and then your where is that inference model? Yeah, here in this inference model you need to change something. Okay, just keep it like this. Just keep the path data local temp and model.bin. Okay, so once this is done, there are some other things you need to do. Now you would need to work with your mobile phone. Let me show you those steps now. First, have a USB cable or whatever cable that suits to connect your mobile phone and your laptop. Okay, so I'm doing that now. Okay, I'm connecting my mobile. Now we're gonna ask some things. It will ask allow USB debugging because I have enabled debugging. I'll just click allow for now. Okay, and it would show my device in the emulator right now. Okay, I'll also show you that later. Make sure you click this allow USB debugging only after you launch the Android Studio, because that is when it will enable you to use your Google Pixel 7 itself as an emulator. For example, I'm using Google Pixel, but whatever mobile you have, it would be fine. Okay, there are some other things you need to do. First, to even enable USB debugging, before that, do this. Okay, it will ask you USB preference, and in this you should click file transfer. Okay, because we would need to load our LLM into our mobile, right? So for this you need it. Okay, so once that is also done, you can move on to developer options, making developer options, so that you can enable your USB debugging, and I will go to show you how if you don't know about that. In settings, I hope it is clear, you can just type build and it will show your build number, and in that build number click it 7 times. Okay, exactly 7 times, and a message will pop up stating that you have enabled the developer options. Okay, so once that is done, now search for system. Inside system, there will be an option for you showing developer options. For me, it is in system, but it might be somewhere different also for you. I'm going to click developer options, and it will have a lot of things. For example, the memory consumption is given as 4 GB of 7.8 GB or 4.8 or 7.8 being consumed. Okay, and the thing which we are most interested in is debugging. In this, for me, USB debugging is enabled, so this is very important. Okay, first you should click your file transfer to be enabled instead of charging. Next, enable developer options, and then inside that, make sure USB debugging is turned down. When you enable the developer options itself, right, just connect your mobile phone when Android Studio is launched, so that when you enable USB debugging, your mobile phone will become an emulator in Android Studio. So now let's see about the code a bit, and then we'll move on to the demonstration, and then we'll also see how you can save this model or the application rather. They are using Kotlin language. Okay, and we are more concerned only about this import, since we are not developing Android a lot. We are just focusing on this LLM inference. Okay, and if you want to change a lot of things, let's say you want to change UI, right, there is a file for that which is UI theme. Okay, where if you want to change the color, you can change it here. If you want the change the theme itself, you can change in the theme.html. It's on your completely. Okay, so you can do that as well. For example, here you can see in theme there is for dark color scheme, light color scheme. They have kept a lot of things. and you can play around with that. But right now let's see about this actually. Okay, they're creating a class with a private constructor which is context. Okay, they're making a private variable in there which is LLM inference, which is an LLM inference object itself. Okay, or an LLM inference class. Here they are setting a variable, a private variable, which is to check if a model exists. Okay, this is a boolean value, and they are just checking if the file exists. Okay, and now what they're doing is, if the file is not existing, it will say the file doesn't exist. But if the file exists, they'll take the LLM inference class and go into the LLM inference options. Okay, so this is parameters being set for LLM inference, and here they are setting the model path, and the max tokens is 1024, which I have set because I have an 8 GB RAM in my mobile. But if you have lesser, then keep a lesser number of tokens in your max tokens. Okay, other than that, there are not a lot of things. And based on this context, which is your context object, okay, this is an Android context object which will give information about your application. It is an abstract class. Okay, based on this context object and the options which we created right now, which is model parameters, it will try to create an LLM inference, and then it will execute that. Okay, that is what is here. Generate response async. It will generate async response. This is using Kotlin. Okay, but if you want, you can also do it in Java. So now what you're going to do is, here there should be an option for you to run the application. Okay, so initially when you run, it will give an error. Okay, for me it won't, but for you it should. Okay, so what you're gonna do is, let me show you. First, here you can see there is emulator as well. So if you click run, right, you'll see your Gradle build running. It will take a few minutes at first, probably. Now you can see it is showing launching devices, right? So now it will show an emulator at side. Okay, now you can see, right, it is showing running on devices. Now it should show me an error first actually. Yeah, here you can see, right, it is showing me an error. So now here what we are going to do is, we are going to use, there is something called device manager here, right? So you're going to click here and click Google Pixel 7, which is my mobile phone, open in device explorer. Okay, that is very important. Click open in device explorer. Now we don't need this. If at first you'll all get this only. So here there will be an option of data. Okay, in data you can just open that. Where is local in there? Here you can see local, right? Local, and inside temp, what you can do is you can just paste your model file. So let's do that now. Where is our model file? Let's check it. My model file is there now. So what I'm gonna do is, I'm gonna drag that and paste it in here in temp. Okay, data local temp. Now it is being uploaded here. Okay, so once that is uploaded, you will see the magic happening. Okay, so right now what it is doing is, it is uploading that Falcon model in my mobile phone actually. Okay, not in my emulator or my CPU itself. You can do the same thing with emulator, but emulator will again run in your system and it will be like pretty huge in computation. Okay, now you can see it shows, just give me a minute, I'll show you. Device explorer successfully uploaded one file. Okay, that is what it shows. I have uploaded in temp. For safety, what you're going to do is right click here and click copy path. Okay, and then go into your this file known as inference model KT and paste the path in here. Okay, that is very important. So once this is done, what you're going to do is, again you're going to click the same. Okay, click in Google Pixel 7. That is what I'm going to use here, my mobile phone. Okay, and in my mobile phone, now I'm going to run this. Let me close these. Run application. Hopefully it would run. If there is an error, let's see how we can solve that. And now it is running actually. Okay, it is running. Let me show you. Give me a minute. So now I'm clicking the run button again. Okay, you'll see the change in here. Okay, I'm clicking run and now you can see it is loading the model actually. Okay, now I hope it is visible for you all. It is loading the model now. Um, since it is a pretty huge model, I think it would take some time for sure. But once it is loaded, you can ask the questions like we saw. And now I'm gonna show you all again. Okay. So let's ask, what do you know about Google DeepMind? Let's ask about that. Okay. Let's see if it is knowing anything. So here I have asked the question, and now the model is trying to see for the answer actually. Okay. So let's see if it is trying to answer it correctly. Already it is taken a pretty huge size, my RAM, and yeah, it is saying an answer like it is a deep learning company, and they more focus on machine learning and artificial intelligence. They focus on model building, inference. There are a lot of things it is trying to say, but it is working actually. Since our demo is ended, doesn't mean like we are completed with the video now. See, I have just shown how you can do it with the help of USB debugging, where you can just open and run this, and then you will be having your result. But that is not as important, right? We need to build an APK file. Now I'll show you how you can do that. Here I was unfortunately not able to find the application directly. So what I did was click the search and type generate signed build APK. Generate signed. Oh, here it will show you generate signed build APK. So click here, click your APK, provide a key store path. Usually what you should do is click create new and then go into your own source directory. For me it is LLM Inference, and if you had followed the video like this itself, it is LLM Inference for you also. And then give a file name stating falcon.jks or whatever file of your choice. Okay, just keep it as yes, and then give your password. Make sure it is easily replicatable. Okay, falcon 123 falcon 123. You shouldn't say to me. Okay, or others are falcon 123. I'm just keeping same falcon 123. Give your first name, last name. Right now everything is test test. This is test, right? So you just give it as test. Okay, just keep it, remember passwords to be enabled, and then click next. And then here there will be two options, debug and release. Make sure your release is clicked, and then click create. And here you should be able to see the Gradle build is running. And soon it will show you the build is done. Here you can see, right? The build is done. Now I'll show you the file directory for this. It isn't here. It's not here. Yeah, Falcon Android is here. Examples, LLM inference. This is our root directory, and Falcon JKs you could have seen here. I hope it is visible. Okay, and we are going into app, and inside app there will be build, and don't go into that. It is release. Yes, you can just export this APK, and then it will work as an application itself in your mobile. Now here you can see in my mobile phone there is the brightness. There is Mediapipe right at the corner. I'll click that. Now it is an APK. Now you can see like my phone is completely detached. I have not attached any USB. Okay. Now it is showing in here, and if I type what is artificial intelligence, it is gonna respond. Okay. And now you can see here it is trying to generate the response. And yeah, it is generating the response. Okay. So yeah, we are also done with exporting and using it as a real application. Okay, and that is how you can run your own LLM in your mobile phone. Now I have shown for Android, right? Similarly, you can do it for any other application of your choice. Let me show that. So in here, it is given a guide for Android, right? So similarly, you can run it for web as well. For web, they would have used a JavaScript kind of an API, where still you need to first create your model by using this LLM conversion.ipynb file, which are also I'll provide it in the GitHub. Along with that, you can replicate the steps as provided in here. Okay, all you need to do is just add the script in your head. Okay, and then you should also install this Mediapipe package by using npm, and then other than that you can follow the steps provided in this GitHub setup which they have provided. Okay, and for the complete code, if you don't want to build anything by yourself, right, for JavaScript you have this one, like they have provided the index.html and index.js, and if you're an iOS user, you can use this one. Okay, I hope for iOS, again, you would need to do it in Xcode. Okay, but this is how you can run your own customized LLM in your Android mobile phone, like I did right now. So I hope you all like this video, guys, because this is one of a kind video which isn't available in YouTube till now. If you all like this video, please hit the like button, share it with your friends, and I'll see you all in the next video. Until then, cheers.